Microphone check 1 2. Camera check 1 2. You know what it is. Good boy, the NetworkBruh. Back with another OSPF lab. I know y'all getting sick of OSPF, right? But y'all know what I always say. Repetition is the key to mastery. Again, this is another OSPF lab. Multi-area OSPF, right? So we got, by the way, we're going to be using Boson Netsim, if you haven't noticed. Let me see what else we got going on in the IT industry. Y'all know I like to keep up with the news here and keep you guys updated as well. While some people trickle into class late here. We learned about this right here. The T-Mobile breach. I guess there's an update on that. Let's see. I'll take a look at that in a second here. Give it some time for some people to tune in here. But I wanted to see what else we got, because we already know about the T-Mobile breach, but apparently there's an update on that. Let's see. What else we got? Y'all hit with that like button if you're just tuning in. I know we just gonna be reading on some news real quick. See, that's why I don't fuck with Computer World now. They don't be giving me stuff that I be needing. Like, I be needing to know what's going on in the networking world. I said networking, and they give me all these old ass articles and shit, man. Let's see. Got another one in here. That's what it was, Network World. And then, I know they were doing some layoffs over there too. Heard about that. Let me add this to my favorites as well. Y'all give me a second here. We'll put it on my personal. Done. I guess we could read about yeah, that's today's news too. Cisco product sales jump, so do some prices. From Cisco's year-end earnings call, its software strategy is working. 400 gig Ethernet is on the march. Chip supply shortages remain an issue. Y'all remember I was reading about an article about chip shortages and stuff like that. That's impacting damn near everybody in the damn IT industry. Cisco's fourth quarter and year-end financial reports highlight growth in many categories that are important to enterprise customers, including wireless, campus switching, routing, and security products. CEO Chuck Robbins said that company's fourth quarter boasts the strongest product order growth rate the company has seen in over a decade. I guess I'm gonna have to invest in Cisco. As much as y'all know how much of a Cisco fanboy, and I do not have any stocks or own any stocks from Cisco, believe it or not. But I should, apparently. I'm gonna see what their prices are in a second. Citing a 30% product order growth year on year and more than 17% order growth versus pre-COVID quarter four fiscal 19 product bookings. In quarter four, we saw double-digit revenue growth. Basically, they sold more money. Sold more. Close that right there. Dismiss this. Yeah, they sold more money. They sold more products. They made some more money. Cisco began moving wholeheartedly into software several years ago, and that move is paying off literally. The company said software sales bested $4 billion, about 31% of the vendor's total revenue during its fiscal year 2021 fourth quarter. The numbers represent an increase of 7% over the third quarter and 6% year over year, Robbins said. The company has said its growth makes it one of the largest software companies in the world, a point it reiterated this week. Yeah, I'm definitely going to have to get me some shares in Cisco. You would think, like I said, as much as I love their products and like, I like computer networking in general, but I guess Cisco, they are we know that they have a large stronghold in the routing and switching environment. So wonder if Cisco pays good dividends. I'm not too sure, man. I'm not too sure. I don't know I don't even know what their stock prices are or anything like that. I never really looked investing in Cisco. You would think I would, but I might have to look at that. I've been doing more. I've been more of a cryptocurrency kind of guy. I just started investing probably like last year, believe it or not. But I have been doing more crypto. Actually, no, yeah, pretty much like the beginning of end of last year is when I started investing. But yeah, I've been doing more crypto. Not paying off for us because we have to study this software define crap. I know, seriously, man, seriously. It's the new wave though, so I guess if you want to really get into a computer network, you really have to know about SD-WAN, right? So, anywho, let's get started with the show. Actually, we got a couple more people coming in. Let's an update on the T-Mobile data breach. Hackers who breached T-Mobile stole personal data for more than 49 million accounts. Well, guess what? The NetworkBruh has T-Mobile, but I changed my password. So there's definitely some more than changing my password I might have to do. I might have to set up some kind of two-form factor authentication or something else to kind of protect myself. But yeah, crazy. PII includes first and last names, date of births, social security numbers, and driver's license numbers. No bueno. As we know, T-Mobile on Wednesday said criminals obtained the personal information of almost 49 million current, former, oh, that's crazy, even former or prospective customers in the latest mega hack of its servers. That's crazy, man. The haul includes customers' first, last names, date of birth, social security numbers, driver's license, ID information for more than for 7.8 million current postpaid accounts, meaning accounts that are billed at the end of each cycle. The unknown hackers obtained the same data from more than 40 million records belonging to former or prospective customers. So even if you tried to get T-Mobile, they got your information. That's just crazy. Who had previously applied for credit with T-Mobile? Names, phone numbers, and account pins. Oh shit, I gotta change that shit too. As a matter of fact, they just asked me about that PIN number. I'm gonna have to change that too, man. That's crazy. For about 850 active T-Mobile prepaid, even the prepaid customers were also stolen. T-Mobile said that additional information, they put that in quotation marks, from an unspecified number of inactive prepaid accounts was also affected. All right, enough about T-Mobile's shit, man. They sent a text today like, hey, you know, there was some data that was stolen. We don't know what was taken, but you know, you should take some precaution. Yeah, thanks. I guess they not they probably should not try to get into the ISP space, man. But I forgot who mentioned that, but apparently they are trying to get into that, right? Crazy. Configuring multi-area OSPF. So yes, I know I'm drilling this shit in y'all head, man. Y'all probably tired of multi-area OSPF, but it is what it is. Y'all know I like using different products and getting different perspectives from different, you know, sources that we've been using. I've been using Boson Netsim. We've done a little bit from the CCNP lab manual. I haven't done my hardware in a while. I haven't used my hardware in a while, but I'll probably fire that up maybe next week or something. But by then, we'll probably move away from multi-area OSPF. So we're going to configure multi-area OSPF right here. This is similar to the single-area OSPF lab that was done in Boson Netsim. But if you take a look, we have this right here. It says pod 1. So we're just going to be working with this side. Yeah, so this side right here, we're going to be doing configuring on. Don't worry about this side, pod 2. Not for now, at least. But for the beginning, we're going to be worried about pod 1. We're going to be configuring OSPF on that side. Then they said here to configure route summarization, which I have yet to memorize how to do, to reduce the size of routing tables and the OSPF link state database. This is the topology right here we're going to be working with. We got some basic commands here. This is one that I need to try to memorize. Route summarization, the command that'll allow us to summarize routes and stuff like that, right? So we got routes to networks. If we got 500 routes to somewhere, to like we could take one route to kind of like make our database a little bit smaller, our routing table a little bit smaller, which will in turn make the latent state database smaller. So basic commands here. We know how to configure OSPF. Let's go ahead and get started. Configure OSPF to operate in a multi-area environment. Configure OSPF on P1, R1, P1, R2, and P1, R3, which are these guys right here. 1, 2, and don't worry about the switch, but 3, right? So we need to configure OSPF on those guys. Use the proper area for each interface. Refer to the topology. But if you look here, it looks kind of confusing here because they want us to do by areas and separate these process IDs too, right? If you don't have Boson Netsim to follow along with me, don't worry. I'll be giving away a copy of this application once I get to about 5,000 subscribers, right? So if you can, go into all of the Discord servers, go into Cisco Learning Network, tell them, hey, subscribe to this guy's channel, man. He's pretty fire. He's got some great content on Cisco CCNA and CCNP labs and stuff like that, and makes it fun, right? Go ahead and subscribe to his channel. You know, hit the like button on all, damn near all his videos, because he's going to be doing a giveaway once he gets to about 5,000 subscribers. I'm about, I guess, what, 50 subscribers or about 500 subscribers away or something like that. I don't know. But help me out, man. Help a brother out, man. This is the give me the help a brother out special. HBO. Remember to configure OSPF to announce the loopback interfaces. So, right, again, process ID 1 or 3. 2, there's also a process ID 1 here, right? They said don't forget to advertise these networks here as well. If an area is an ABR, if we look over, we have only 2 ABRs here, which is this guy and this guy, right? It's basically a router that borders 2 areas. So in this case, area 1 here and area 0 here, which is known as the backbone, right? So he's an ABR and so is he. He is also an ABR. And then they also said you should use the process ID for the router shown in the topology. So these are the process IDs again: 2, 3, and 1. On P1, R1. So let's go ahead and get started. I'll start with R1, right? Since he's the first one. Make sure y'all hit me with that like button, man. Like button, man. I'm gonna keep drilling that shit in y'all heads, man. Enable global config mode. We said, let's take a look at our interfaces. We have 192.168.1.33. We have 192.168.1.1, and we also have this guy who sits in the 10.100 network. So we'll probably need a statement that's gonna catch both of these guys right here, which will probably be we could just do 1.0. I guess we could do /24. That'll catch both of them, right? And then we'll do a network statement for this one. But don't forget, we need to pay attention to these areas, because this is what? Multi-area. We got 2 different areas here. Actually, we got 3 different areas, right? So they say router OSPF. What process ID we want on the first one? We want process ID 1. I guess we'll do 1 for these guys right here, right? Because I don't know if that means this one needs to be in process ID 2, but I'm going to say, I guess that'll be, yeah, that should be process ID 1, right? Yeah, so we'll go with 1, right? It's going to be any number between 1 through 65, 135, right? We say network. Let's do a network statement that's going to catch the 10 first, because that should be an easy one. /24. So we say 10.100.100.0/24, which we don't work with wildcard masks. I mean, we don't work with subnet masks. We work with wildcard masks when we're doing network statements, right? So 255. And they didn't say whether they should be interface specific, so we could have done that too. Areola. 0. Yeah, that should be in the backbone area. So 0. I guess that should make us. Theoretically, that should make these 2 guys become neighbors, right? If he is also broadcasting, if this guy is broadcasting OSPF in that network, then theoretically these 2 should become neighbors. If we get if not, then we'll figure that out. And let's do another network statement for the other side. Y'all got any questions so far, or am I losing anybody? Let me know if there's any other. There's a lot of smart people in the chat room. We got Pete S in the building. Appreciate you for tuning in. Does summarization just mean having fewer network statements so it applies to more routes? It could be that, but not necessarily fewer network statements, but a network statement that will give us a smaller routing table, and it will. Yeah, it'll give us a smaller routing table. It'll make the link state database a bit smaller as well. What else? And also, when we work with OSPF, we work with, when we summarize routes, we use this command right here. Area, and then the area ID, and then range. This one summarizes OSPF routes at an area border router. So not necessarily less network statements. We use this right here. There's another one for BGP and EIGRP. We use the area and then the area ID, and then range command. That summarizes OSPF route. So that's a really good question. I like that one. Juan said MultiArea is a cool lab. Yeah, this is a cool lab. Yep. So I'm using Boson Netsim. We got Diane Foster in the building. Appreciate you for tuning in. Yeah, I meant broader, meaning it catches more routes. Yes, exactly. But we don't use network statements to summarize our routes. We use this area range statement command to summarize our routes. So that's a really good question. That's a really good question. I like that one. And notice we have a neighbor now. So these two guys right here became neighbors with that network statement that we did that caught this one. So let's do another one for the 192.168.1.0 network, right? These guys right here. And I guess that should be the same process ID. Yeah, router OSPF1. So we'll just say network 192.168.1.0 should catch both of them. 000.255 area yeah, so I guess these two should be in area 1, right? Because that interface right there sits in area 1. But I don't know what that loopback. Being that it's a network statement that's in a 192.168, I'd say this is area 1. So meanwhile, this is in area 0. I just don't like how they had this loopback sitting out here. It don't look like it's in that area or that area, but this IP address kind of gives us a clue that it should be area 1. So we'll say area 1 for that. And I don't, unless this guy is a neighbor, unless this guy, no, we got to configure OSPF, so he's not gonna be a neighbor yet. So let's go to him and go to global config mode. We say router OSPF, router OSPF, and then the process ID should be 2, right? To catch both of these statements and that one to these interfaces. I say 192.168.1.0/24 and then process ID 2. So we process ID 2 for that, right? We say network 192.168.1.0. We say 000.255 area. What area is that? This is area 1 this time, right? So this is area 1. So area 1. And then I think, yeah, that should make these two guys become neighbors, right? These two guys right here. He said, oh, okay, I'm not seeing the range command yet. I'll have to pay attention to this one. Yeah, so the range command, again, is what's going to you use to summarize your routes. And they have one like that for EIGRP and BGP. I just can't remember what the summary command does for it, or what the exact command is to summarize routes. And there they go right there. They just became neighbors. Process ID 2, 192.168.1.1. So yeah, now these two, this guy and this guy's neighbors. Now let's go to this guy right here to make them two become neighbors. So we'll go to router P1R3, this guy right here. And we go to user exec mode, then global config mode. We say router OSPF, and the process ID should be process ID 3 for that side, right? 3 right there. We almost done. We should be a quick one, and then we gonna knock this one out because I don't want to do another lab tonight, man. I'm sorry, y'all. And I did not set up a quiz. We should start doing those quizzes again, right? Those were fun, man. It just take a minute to set them up and test them and all of that. So we need a network statement. I say the same network statement should work for that one. 168.1.0 000.255. Y'all with me so far, right? Same area, same network statement, but a different area. So area 1, and then that should make them two become neighbors. These two right here, because this guy's a switch, so don't pay attention to him, right? He's not part of layer 3. He's layer 2. We can also see if he is coming up. We can see OSPF neighbor. There it is, right? See, now we're in the X start. It's not a neighbor just yet. Running again, exchange. Remember those neighbor states that Pete sent us that document to? And now they became neighbors right there. Adjacency change. So we should be good there. And this was a chart that I had that I was going to bring up to do route summarization because I don't remember how to do that shit by heart. I just know you got to break it down by binary, count the number of zeros and stuff that, count the zeros and ones that match, and then that'll be your subnet mask. But we'll worry about that in a second. So what was the next thing? So now I think they should all become neighbors. So the next thing is, let's see here. On P1R1, display the routing table. So we go to P1R1, which is located here. And we do a routing table check with show IP routes. And what do they want to see here? What type of routes are in the table? O, IA, E1, or E2? Well, we know that we have some O's here. That lets us know that it is a what? A route that is learned from OSPF. OSPF, right? What else we got here? We got some connected in local routes, obviously. And then we have some that start with O, and IA. And the IA stands for intra-area, or inter-area, rather. Inter-area. There it is right over here. When you look at the legend right there, right? I don't want to highlight it because it keeps going down. So, see, look. Boop. There it is right there. So that means inter-area route. So we have O's and IAs. We don't have any E1s or E2s, which stands for OSPF external type 1 and OSPF external type 2. So no, we don't have any of those type of routes in there. I don't see any. Nope. Just connected local OSPF and OSPF inter-area routes. All right, so from P1R3, so from this guy right here, bloop, that guy, ping P2R3's F800 interface, 192.168.2.50 to ensure that you have connectivity to all areas in the network. The ping should be successful. Should be. So basically, they want us to have P1R3 ping P1 or P2R3. Basically, they just want us to go ping to make sure we have full connectivity this way, right? Remember, we didn't set up anything over here. That was already done for us. So if OSPF was set up correctly here and we did it good on this side right here, then we should be good to go, right? We should have a happy face looking like that. Let's go to P1R3, and he said ping 192.168.2.50, and looks like we got a reply, 5 exclamation points, right? So it did go across. What's the next thing? It says here on P1R1, review the database of link state advertisements. Yeah, y'all know I have not memorized the link state advertisements yet that are exchanged among routers, right? There's what we said, there's 11 LSA types. For the CCNP exam, we need to know at least the first like 7 of them, minus the type 6. So really 6 of them we really need to know. So let's go to P1R1, look at his link state database. How do we do that? We do with show IP OSPF database. And then we said, and we have multiple areas, so it's going to be big as hell, this database, right? So remember we said this is a type 1 LSA, right? This gives us, if I remember correctly, who are OSPF neighbors that are directly attached to us in area 0. So this is type 1 for area 0. Right, so type 1 for area 0. So here's area 0 right here, down here at the bottom, right? That's area 0. And this LSA tells us who's attached to us. We have 192.168.1.1 and 2.1, this guy right here. So who's 1.1? Is that me? Can't remember. Router ID 1.1. Let's see. We know that he should be 2.1. That's 2.1. Let's see. On this. That's me. Shit, that's me. So I'm 1.1, and then 2.1 is this guy right here. So that's what the LSA for area 0 tells us. Type 1 LSA. What else? They just want us to review the database. They ain't have no other configuration or anything like that. The other type 1 is over here at the bottom. So for area 1, we have 3 type 1 LSAs. One with the link ID of 1.1, 1.17, and 1.50. Who are those? 1.1 is me. 1.17 is this guy. And 1.50 is this guy. So that's who is attached to us in area 1. Right? Now I think I remember the type 1s. That's probably the only one I remember of the 7 that I need to remember for the CCNP exam. This is a type 2 for area 0. Y'all got any questions or anything? He said LSA types help you with their name, e.g. router, network, and summary. Yes. LSA types help you with their name, router, network, summary. So that's 1, 2, and 3, right? I know that. I think that's what you're saying there. So the first one is router, is type 1. The second one is network, so type 2. And the third one, summary, LSAs. Foster, you said loopback. What you mean? Can you break down what you were trying to say exactly? What else we got here? So let's go back to the area 0. So this is type 2. I know that. This type 2 LSA, right? It says we got that from 192.168.2.1. Who's that? That is this guy right here. That's this guy right here. So we got a type 2 LSA from him in area 0. And that's the link ID. And what was the type 2 LSAs? Y'all remember? Does anybody remember? Let me pull up. I'm going to pull up that Discord server. And in case you guys don't know, I have a Discord server. In case you're tuned in for the first time, make sure you're joined in. Here's the link to the Discord server. In there, we share a lot of information. Anybody have any questions, or sometimes if I cancel my stream. Oh, I apologize for yesterday. I canceled my stream and didn't even let y'all know. I was just like passed the fuck out because I was busy at work and shit like that, man. What was so busy about work yesterday? I don't even remember, man. It was just such a blur, man. But I was just like, man, fuck streaming, man. But anyway, Drexor said, are these labs for NA or NP? This is configuring multi-area OSPF1, which falls under Encore. So this is considered a CCNP lab, according to Boson Netsim. I'm using Boson Netsim. She meant the type 1 router LSA was showing the loopback. Oh, okay, gotcha. Yes, type 1 is showing the loopback. Type 2 is network, yes. And then type 3 was summary, right? If I remember correctly. But I was going to say, yeah, make sure y'all join that Discord server. Pete put in a great link, an article on that breaks down OSPF LSA types. Shout out to ipwithease.com. That's where he got it from. And it has good, like, how I say, like diagrams and stuff for each of the LSA types. I have yet to memorize those motherfuckers, man. I was just studying them like last year, and I'm like, I'm gonna break these down. I'm gonna remember these. I'm gonna remember these by heart, man. I've made flashcards for them, and I forgot about them. Anyway, yeah. So type 1 LSAs are router LSAs. Type 2 is network LSA. Type 3 or 4 is summary LSA and ASBR. So we said type 2. This is a network LSA. We looked at the type 2. And this type 2 for area 0 right there. 10, 100, 100.2. So type 2 LSA, which tells us it is generated by the designated router on the broadcast network. It includes the network ID, which is, that don't look like the network ID for area 0. This the 10.100.2 network? No. Well, that's the advertising router. Anyway, what else did they say? It includes the network ID, subnet mask, and also a list of attached routers in the transit. We see this as O routes in the routing table. What was the other question? What did you say? What'd you say over there? Okay, so what else we got here? I'm gonna look at the type 3s and then we're gonna move on to the next one because we need to do some summarized routes and then we're gonna call it a night. So this is the type 3 for area 0. So notice type 3 is a summary net link. They call it also, like he said, is the summary LSA. Where is it at? LSA type 3 summary LSA. The type 3 LSA is used to share network information with other areas. Inter-area route. So when we did the show IP route, this right here, all these are given to us by type 3 LSAs, all the IA routes. Those LSAs are advertised by the ABR. These LSAs are represented in the routing table as OIA routes, which I just explained. To flood the information through autonomous system, they are regenerated by the ABRs following subsequently. What else can we say? Let me see. What else can we say about type 3? So we got type 3 LSAs. Here's the link ID, 1.1. So these are the interfaces right here. and then the advertising router. So this is me actually flooding these. And then this guy right here is flooding the ones for area 0, which is he's 1.1 and he's 2.1. So those are the only two. And like they said, ABRs are the ones that give the type 3 LSAs. Since these two, since this guy and this guy is bordering two routers, right? Or two areas. He's bordering that area and he's bordering this area. He is therefore considered an ABR. And that's why he's the one that's flooding all of the type 3 LSAs. Same thing with this guy. He borders that area and he borders this area. So he's flooding type 3 LSAs. That's what I need to remember. It contains network ID and subnet mask, which we've already kind of seen there as well. Okay, so that's all they wanted us to do is just review, review the LSAs that are exchanging more route. I'm not going to look at the rest of them. There was just so many of them in there. Display information about each device's neighbor on a per interface basis. God damn, man. All right, so let's go to this guy, and we'll just do this interface and then that interface, and then I'm going to move on because I'm not going to do each neighbor's interface, although that would be a good breakdown. We'll do show IP OSPF interface. What interface is that? First one is serial 00. So we say serial 00 and display information about it. What they want us to see. This is a point-to-point network. Default OSPF timers, right? Hello's 10, dead is 40 for a point-to-point network. Remember, they're different on a point to multi-point. On point to multi-point, it is 30 hello and dead is 120 on point to multi-point, right? That's why I used to get confused because I was like, they're all the same. No, they're not. Not all of them. What else can we say here? The adjacent neighbor, we're adjacent with the neighbor 1.17 on that interface. Who is that? 1.17 is this guy on that interface right there, right? I'm not going to do all of these interfaces here. So we'll just look at, let's just look at this one right here and then move on to the next question or whatever. So that interface was FA00. So we say OSPF interface FA00. Got any questions or anything? Or am I losing anybody? Or am I just talking? Advertising is the DR. Advertising is the DR. So advertising router is the designated router for what? Type 3? Is what you're saying? If that's what you're saying. Oh, so on the other one, we have, this is a broadcast network on FA00. So from P1R1, we're saying this is a broadcast network, whereas this is point-to-point. And I think most likely because this is point-to-point. Let's see. This is point-to-point, bloop, 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 because it is serial. And did they put point? Let me see. Did they put the, how do they verify? Let me see real quick before I explain that. Serial 00. Let's see what they got in there. That's why they made that side. No, that's not why. Let me take a look at the other one. FA0. Oops. FA00. They said no IP directed broadcast. But one side is broadcast, the other one is not. So this is this considered a broadcast network. That's considered point-to-point. I'm guessing because of serial, but there's more than one host address in there, so I don't know. Anywho, let's see. Broadcast network, the interface address. What do they want us to break down here? Display information about each neighbor's device's neighbor on a per interface basis. Designated router is this guy, which is 2.1 is him. Right, he's 2.1. He's the designated router for that network. What else? When the hello is due. What else do we see in here? That's pretty much it. Suppress hellos for neighbor. None. That's all. That's all. I'm not going to do every interface. Display information. Display OSPF interface information. I did that already. Maybe devices neighbor. Maybe they wanted us to see. Let's see. Let me do show IP OSPF neighbor too. Let me do that. So P1R1, obviously he's got two neighbors, right? Two OSPF neighbors. He has this guy as an OSPF neighbor, bloop, and he also has that guy as an OSPF neighbor. And it tells us where we learned it from. My interface, that's broken down right here. I learned about the 2.1 guy on my interface FA00, and I learned about 117, this guy right here, 117 through my serial interface, right? My serial interface. And that's what I need to remember. Somebody told me that this interface is the remote interface. No, this is my local interface, even though it says this is the neighbor's information. No, that is my local interface. Is how I learned about my two neighbors. Remember, he is the designated router on that network segment. Display general information about OSPF. We can just do show IP OSPF with that. Show IP OSPF. We'll see what this breaks down. This breaks it down by area first, right? The first part of it gives us, no, by process. So the top one gives us process ID 1. This next one gives us information about process. So I only got one process in here. I thought I would have had two. No, it's one. It breaks it down by area. My bad. Breaks it down by area. So area. Jeez, I hate this. So you can't even. Okay, so area 0 here. Area 1 here. Down here. I guess you can't even do that. Okay, so area 0 here. Number of interfaces in here. 1. We have 2 in area 1. 2 interfaces in area 1. Oh, because one of them is loopback. We have this in area 1. Sorry. Yeah, this in area 1 and that in area 1. Meanwhile, this is in area 0. So that's why they said that there. How many times the SPF algorithm was executed? Right, pretty much the mathematical computation to figure out the OSPF route. What he said, I think for type 2 in the output, advertising is the designated router. I think the default network type for Ethernet is broadcast, and serial defaults to point-to-point. Now that I did not know. That is food for thought. Y'all do the dishes. I like that one. See, I didn't know why. I was looking for it. I thought there was a command on why they did that. So the default network type for Ethernet is broadcast, and serial defaults to point-to-point. That is a golden that's golden knowledge right there. I'm glad you put that in the chat there, man. Thank you for that. What else? Yeah, I guess it just gives us a wealth of information here. Let's move on to the next one and then call it a night. Configure OSPF route summarization on P2R1. Who is that? That is P2R1 on this guy right here. They said display the routing table. How many routes to pod 1, which is right over here, pod 1, right? This guy right here. How many routes to pod 1 does this router have? So let's go to that router and find out. Where is he at? Got so many fucking windows here open. P1R1. Jesus. Topology. P2R1 rather. There's a show IP route, and we'll see. We have so many goddamn routes. We have how many? What they wanted to know? They wanted to know how many routes to pod 1. To pod 1, we have all these inter-area routes. So we got 1, 2, 3, 4 to each of these networks, right? The 1.1 network is the loopback, right? That network right there. We have one to the 1.17 network, which is this right here, the other loopback. We have one to the 32 network, which is this over here. And we have a fourth route to the 48 network, which is this right here. Pod 1 uses 4 contiguous Class C subnets. How can you summarize the 4 subnets with a single summary route? Well, we can use this chart that I had here. This is like kind of like a calculator I used to use to figure that out, right? But I forgot how to do that shit, so I just Googled the route summarization calculator. And I know we definitely need to know this, like know how to do this shit by hand. But anyways, I pulled up a route summarization calculator. I Googled it. So basically what we want to do is put all of the networks for those networks and then see what's going to give us a summarized route, right? So if y'all want, I can give y'all this link and then y'all can favorite it so you can figure out how to summarize routes. But that's it in the chat right there, right? Basically what you want to do is put each of the routes in there and it'll tell you what the summary route will be. So we need a summary route that's going to take each of those 4 networks, right? We have 1, 2, 3, 4, and have just one route that's going to take us to all 4 routes in pod 1, right? So that way that'll memorize our routing table. I know it's only 4 routes to 1, but imagine you have a large enterprise network that's got like 50 OSPF routes, right? Well, you can do some route summarization to knock it down to like 1 or 2 or 3, maybe 4 routes or whatever, right? Puts less process on the CPU, and then the router ain't gotta work so damn hard. 192, we put the subnet. We said they are 192, 168. What? 1.1.0? I think, yeah, like say 1.0. Let's say 192.192.1.0 subnet, right? .0 subnet. .0 subnet. What else we need? We need something for the, let's see. Yeah, that's going to be for the 1.0 subnet. We need another one for this one, which will technically the 16.0 subnet, right? 16.0 subnet. So let's go back to my little routing calculator. And no, you can't use the routing calculator, the summarization calculator on the exam. 16. So that should be, I think, the 16.0. Yeah, I guess the 1.16 network. Yeah, so that should be the 1.16 network. Yeah, 16 network. This should be the, I guess that's the 32 network. Yeah, that'd be the 32 network. And the next one will be the 48 network. 17 network and 48 network. I think, yeah, that should be good enough. That should be good. So back to that calculator. Where you at? 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 Bloop. Damn, I'm gonna close this one because I'm not gonna use this one. I'm not gonna use this one. We need to come up with a good summary route. 16, 1.16. Did I say 1.16 or did I say, yeah, 1.16. Next one's gonna be 1.32 network, which is over here. Let me make this a little bit so that way I can see. I can reach all of them. 1.16, 192.168.1.32 network. Is that 32 network? Yeah, I think that's 32 network. And that one should be the .48 network. 1648 network, right? Am I correct in saying that? Let me see. He said one. That is, I like that summary route, but that's so very broad. That's a very broad network statement, man. That is gonna catch all of them. It will, but you can actually make it more. How do I say? Yeah, we can come up with another network statement that's going to make it. Let me see. 1.32. I can't remember what was the other one. Let's see. Oh, the other network statement. The other network is 1.48. So 1.48, 1.32, 1.48. 192.168.1.48 network. That should be it right there. One, because see this, I know you know what, that route, that exactly, it'll be more specific. So this network statement right here should catch all of them. And this is how I should have done it to learn it, to know it. You have to break down the number in binary and then count up how many zeros and ones they have in common. So in this case, they have, well, this tells us right here, 26. How will you know? We got 8 plus 8 is 16. Plus another 8 is 24. And then they have the rest of these right here. So 25, 26. They have all those numbers in common right there. See that? Let me show you. They have that in common, that in common, that in common, and then that in common. So that's why it's 192, 168. They already have these all in common. 68, 1.0. And then to get to that last part, we need to say how many are in common. So these last two right here, right? And then that gives us 26/26. That's how you know what summary route you got to do. Now, to do it by hand, I can't, like, not that I can't remember. It's just, like I said, that Excel spreadsheet that I showed you is how you can, like, come up with a summary route. So now we have to go, let me see what they say here. Configure the summary route you noted in the previous step on pod 1 and the pod 2. So we need to put that in the summary route on this one and this one. But we need to pay attention to the areas too to do that. So we'll go to P1R1. And we need to summarize the routes that are over here and summarize the routes that are in here, right? So go to global config mode. We go to that routing process, which was router OSPF, what was it, 1? That was router OSPF process 1 for that guy right there, right? We said to do that command, remember I said to do a summary route, you do the area range command. So area, question mark, you'll see what is the area you want to summarize. So in this case, I want to summarize everything that's in area 1, or as they called it, pod 1, because they said to summarize all the routes in pod 1, but we put it in area 1, right? So in this case, area 1, and then you put the range command is how you summarize routes using a matching address / mask, right? So in this case, range. And then you put in the address that we calculated in our little route summarization calculator. So shout out to securitysite.com for that. And no, you can't use route summarization calculators in the exam. So 192.168.1.0, and then the IP mask, which in this case is /26. But you got to do that. You can't just put in /26. You actually have to type in the subnet mask for /26. So in this case, it's 255.255. /26 is 128.192 like that. And then you say we did the area already, so and that's it. That is a summary route for pod 1, right? So now I think if we go to this guy right here, remember we had those 4 routes. Theoretically, we should have a summary. We should see a summary route in here. If we do show IP route, let me see. Show IP route. And now notice we only have 1 route that's going to take us to all the routes that is in here. You see that? That's how we did that. So we went from a routing table that has all these damn routes that take us to all these cities, right? And it just said, hey, man, go ahead and take I-10 to take you to all of those cities, right? It's just like we had one route that's going to take us out of our state that's going to take us to the rest of these other states, rather than one individual like, I guess, highways that'll take us to different states or whatever, if that makes any sense, right? Yeah, I know, like comparing network to roads and highways and stuff like that, right? So that's our summary route. Nothing in here tells us that it's a summary route, though. I think EIGRP does that, though. I think EIGRP does that. What he said. Okay, I see the binary, but you can do it with the magic number method too. Yeah, I think there's so many ways to do it, man. But like I said, I used to do it using that little spreadsheet that I came up with, and that's how I do it. And you have to just see all the numbers that are in common with all of the networks. Count that, and that gives you the subnet mask. It also gives you the network mask too, the network you want to use. The highest number is .48, and /26 counts in 64s. I'm gonna have to rewatch that. You make my head spin right now. So at the end of this stream, I'll probably watch this, I'll replay this, and I'll try to read that. But this is how I kind of know how to do it. I know I'm kind of cheating with this route summarization calculator, but yes, you take the number down and write each of those networks in binary. Count how many are in common with all of them in binary, which in this case 24, and then 25 and 26, which they all have 26 in common. That gives you the subnet mask, right? So /26. And then as far as the network address that you just use the network address that they all have in common, that are like contiguous, I guess how to say. So in this case, that's what they all had in common, right? And then the last 2, don't even worry about that for the network statement. Just add those 2 to the subnet mask. I need to remember that. The way I explained it to you, that's how I need to remember it, because I'll be forgetting, man. I'll be forgetting. Anyways, let's go to P2R1, this guy right here, to summarize the networks that is in this right here. Because essentially, remember, we have a network here. That's one network. we have two networks here, and we have a third network here, and then let me see, yeah, 1, 2, 3, 4 networks there. I think we probably got 5 if this is the case. That's going to be advertised to him. Let's see. Let's go to him and see what does he see for his OIA routes. Let's see, because he don't have no summary routes to the 2.0 network, right? Show IP route to the 2.0 network. I've got 4, so I've got those 4, right? In the 2.0 network right here, 2.0 network, which is essentially this side right here, we got 4 routes to those. 1, 2, 3, 4, which is 117 or the 1.0 network, 1 network, 16 network, 32 network, 48 network, right? So 48 network. Oh, that's why I broke those down. I looked at that switch. This is one whole network here. That's one whole network. That's the 48 network. This the 16 network. Actually, yeah, this is 16 network. This is the 32 network. So 1, 2, 3, and then this is the 2.0 network, I guess. Yeah, that's the 2.1, pretty much 2.1, but 2.0 network /32. So whatever. That's the 4th network. That's why we have 4 in the area routes here. And then we'll do the same thing here, but we're going to say 2.0, right? Because essentially we'll do another statement, network statement again. So 192.168. We said the 2.0. Next one is going to be 192.168.2. What's that? 2. Let me look again. 2.0 and then 2.32. Where you at? 2.32. Next one is 192.168.2. Where you at? 2.16. 2.16. And the last one, 192.168. Y'all hit me that like button, man. If y'all see what's going on here. He said, wrong router. Oh, I was in the wrong router. Let me see. P1R1. Oh no, I was doing P1R1 to see the routes that are in here. If that's what you, I'm not sure if that's what you were saying, but I do need to go to this route right here to configure the next summary route. The last one is 192.168.2.48 network. Yeah, 2.48 network, I believe it is. Analyze. It's the same thing, but 2.0. Right? How do we come up with that? We said, of these networks right here, all what they have in common, we already know they have the 192.168.2.2. So 192.168.2, 192.168.2, and 192.168.2. They all have that in common. So we know that's going to be part of our network statement. Right? The 2.0 network statement. It's this part right here that's what kind of like throws me off a bit, only because I have to convert the number to binary, and not that I don't remember. It's just like I said, I need a damn Excel spreadsheet to break the number down in binary. So we said we have 8, 16, 32. I'm sorry, 8, 16, 24, and then 25, 26 in common. That's how we come up with the subnet mask. Right? That makes sense? Okay, got it. Okay, yeah, so I'm sorry if I confuse y'all, whatever. But yeah, that is how we come up with the other network statement. Not network statement, but the summary route. So now I'll go to P2, who we go to? Now we go to this guy and summarize. So now this is from router 1's vantage point, right? I'll show you all real quick. So that way y'all got confused. But I see where you got confused from, though. So this is P1R1, right? He sees those 4 networks in the 2.0 network, right? Sorry. The 48 network, 2.16 network, .33 network, and the 2.0 network. We're going to do that summary route to condense them into one. He says /26 catches 0 to 48. Okay, I'm going to remember that too when I replay this. So we right at the hour too, so we should be almost done. So now let's go back to router config mode, router OSPF1, do another summary route. And we said to do that. No, I'm sorry. Did I do it on the right side? 2.0. Oh, so I need to go to him and put in the summary route over here. And make sure, yeah, that's what I got to do. That's what I got to do. Okay, so now global config mode router OSPF. What is that? 1. And we say area. What is that? Now I'm going to summarize the routes that are back here. So I'm going to summarize the routes that are back here. So you summarize the routes that you know of, and then advertise it to these guys. That's what you do here when you do this, right? I guess that's probably why I got confused or whatever. Y'all disconnecting. I see y'all disconnecting over there. I guess I got bad internet. So now area 2, and in our network statement, so we got to say range, and then our not network statement, but our the summary route that we came up with was 192.168.2.0. We said the subnet mask is 255.192. Press enter. So now we go to this guy, and we last saw, how many routes did we see on this side? Oh, I didn't even see. Yeah, that's what we did. So see, we had 1, 2, 3, 4 routes. Now that he's advertising a summary route, we should see just one route. 192.168.2.0. How do you get there? 10.100.100.2. Who is that? That is this guy right here. So to get to the 2.0 network, that's your next hop, right? That makes sense? I hope that makes sense. So now, what else they want us to do here? Configure the summary route. Verify that the routes are summarized, which we just did. The ABR should see specific routes to those for those areas in area 0. You should also see the summarized routes for the other areas. How many routes does pod 2 have to pod 1? Like we said, we only got one route for each one of them. We have summary routes. How about one of these other guys? Do they have summary routes as well? Let's see. Show IP route to get to the 1.0 network. Yep, he has one summary route right there. Same thing probably with this guy. I should have ran show IP route to see all of them, so that way we can see them all condensed. Let me refresh because I can't see y'all. Y'all disconnected from my chat. I hope y'all can still hear me. Let me know. Hit me with a bruh if y'all can hear me. And make sure you subscribe. Make sure you hit that like button. We're going to wrap it up here. Matter of fact, let's just see. I think we have summary routes. We came up with a summary route. I'm just going to check him to see if he has summary routes to the 2.0 network, which is also known as pod 2. Let's go to that guy and do that. Show IP route to get to the 2.0 network. We have a summary route. So now let's see if we could ping all the way across, and we'll call it a night. I guess I should have done that earlier, right? 192, what is P2R3? P2R3 is, oh, we did do that. He is 192.168.2.50. Ping 192.168.2.50. Get on these, put it in the network, guys. We got 5 replies. We good to go there, man. Y'all make sure you subscribe to your boy. I typically stream Monday through Thursday, 8 p.m. Eastern Standard Time. We're going to go ahead and wrap this up. If you guys want to know if I do cancel a stream or if I do a bonus stream on the weekends, which I'm not going to do this weekend, make sure you join the Discord server and I'll let you know. Sometimes, if I'm on top of my shit, if I cancel my stream, I'll let y'all know in the Discord server as well. So that's the link to that's the invite to the Discord server. Again, y'all make sure y'all let other people know on the Cisco Learning Network. And today we did Boson Netsim. Sometimes we'll do even G. Sometimes we'll use my dusty old trusty dusty hardware. Sometimes we'll do GNS3, which we've rarely done. Sometimes we'll do Package Tracer. So I'll mix it up on this channel. If you have any requests, let me know on the Discord server and something like that. What else did I wanted to say? Next week, we may do more OSPF. I don't know. We'll see. But if once I get to 5,000 subscribers, I'll be gifting away a copy of Boson Netsim so y'all can do it along with me and stuff like that. In case I mess up, or you guys can help me out. And this is a learning environment. I'm not just showing y'all everything I know. Thanks for showing me range and summary. Yeah, so the range command. There's also one like that for EIGRP. There's also one like that for BGP as well, but it's called the aggregate command. You can look it up, Google it real quick, and you'll see it's called the aggregate command. That's how BGP does it. EIGRP, is like EIGRP summary route. I can't remember, but either way, they all have their like ways of summarizing a route. But the way we compute it, that's the same exact way. I just did it on a calculator. Just remember, for CCNP or CCN exam, you can't use no calculator like this, the way I did it. It's just easier for me to explain and shit. So, what else I wanted to say? Yeah, that's it, man. Oh, I haven't really promoted this in a minute. The little study spreadsheet that I came up with for the Encore exam. This is kind of a kind of like a spreadsheet that I came up with, study plan for the Encore exam that I came up with, right? I've been quasi following. Basically, I took all the exam topics and put it in this spreadsheet right here and broke down where you can find information on, let's say, for example, OSPF, right? We're doing OSPF, right? Where's OSPF? OSPF. Let's do a Control F. That's what I like about spreadsheets too. OSPF. There it is right there. We did a couple labs on OSPF, right? Route summarization. Oh, there's also some links to some videos. So OSPF. What else? There's some more in here. I know there's more. There's OSPF stuff right here. You can find it in chapter 6 in the Encore exam book from Cisco Press, right? I also have some YouTube links. If you have CBT Nuggets, there's some links there as well. But you might have to like break some of this stuff down because I forgot I had CBT Nuggets, so I was just putting YouTube links on there from some other channels and stuff, right? The 101 Labs book, which we haven't done in a while. I need to crack that one open. Where you can get OSPF labs from. GNS3 Volt, where you can get some labs from in there as well, but they have various. That's why I put various there. The Boson Netsim, which y'all know I love that application. There's various OSPF labs in there. But anyways, this spreadsheet breaks down a lot of stuff that you just have to make sure you have this book, that book, Boson Netsim, which I'm going to be gifting away once I get to 5,000 subscribers. The GNS3 Volt. That's a link. They have all the links in there as well if you want to get to it, right? So like BGP troubleshooting, there's a link for that, etc., etc., etc. So anyways, for now, comment, like, subscribe to the network.